Okay, our job is to read the directions. So it says for each of the following data tables, write an equation using t squared as the base that could be used to create a simulation. So we have an input here, variable time in seconds with the variable name t. We have an output description as it's the position of a ball relative to the floor in feet p. So we have a function of time, or the output is the position of the ball. We have 3 data points. At 2 seconds, the position of the ball is 0 feet off the ground. At 4 seconds, the position of the ball is 13 feet off the ground. And at 6 seconds, the position of the ball is, again, 0 feet off the ground. So we've got a symmetric case here of 2 and 6 seconds. The ball is at the ground, bouncing. Bounces here at 2 seconds, gets to a peak, it says here, at 4 seconds, and gets to the ground again at 6 seconds. We know it's the peak at 4 because it tells us that this is a critical point. Okay. Now we're supposed to use t squared as the base. Okay, and we know that there are 3 types of manipulations on t squared. We can do a multiplier on t squared, like 3t squared. We could add or subtract something on the inside of the parentheses, like t minus 3 squared, or on the outside t squared minus 3, or a combination of any of those. So that's what we're going to use. Now remember, the method we began using in class uses the critical point as the 2 manipulations, one on the inside and one on the outside. So to explicitly show the procedure that we used, it looks something like this. You begin with t squared, but you use the critical point here. So instead of writing simply t squared, you write the position is equal to blank, we don't know the multiplier, times, in parentheses, t minus 4 squared plus 13, where the 4 comes from the time and the 13 comes from the position at the critical point. Remember, we do this because we want to design a function where this point will make the function true. And we notice that if we substitute a time of 4 into this, 4 minus 4 is 0, squared is still 0, times the multiplier is still 0, and it gives us a position of 13. So we've successfully created a function that has this as one of the data inputs. Now we simply needed to have one of the others, and since all of this data is going to be symmetric, we know that checking for 1 will get all 3. So the time is 2, the position is 0. We also need it to work for that. Now instead of using a blank here, we're actually going to use a variable. We'll call it a. Alright. Now we're simply going to put in the time of 0 and the position of 0, because if we put a time in of 2, so in other words, if we write a times, in parentheses, 2 minus 4 squared plus 13, in other words, we put a time in of 2, we want the position output to be 0 in order for the function to work. So now we simply need to solve, forgot the squared, we need to solve this equation. Well, if we examine the equation, we know that this whole thing plus 13 needs to equal 0. Therefore, this whole thing needs to equal negative 13. So that's our newer equation. A times 2 minus 4 squared. We know that that needs to equal negative 13 through our reasoning from above. Well, let's simplify this a bit. A times something is equal to negative 13. Let's figure out what that something is. 2 minus 4 is negative 2. And that's being squared, and we're still multiplied by a, negative 13. And negative 2 squared is negative 2 times itself, which is positive 4. So we have a times positive 4, which is more regularly written as 4 times a is negative 13. And now how do we find this? Well, we simply divide both sides by 4. Okay, that's going to, 4 times what is negative 13? Well, you answer that question by dividing negative 13 by 4, and you get that A is equal to, well, we can just leave it as a fraction, negative 13/4. And that's the mystery multiplier from above. So to finalize our answer, it requested an equation. Okay, we simply write that the position is equal to negative 13/4 times parentheses t minus 4 squared plus 13. Okay, this is going to give us a function of time that uses t squared as a base, that will contain this as the critical point and these two other points. Okay, so that's the method, and this is simply a way to practice this. There's a number of them on the sheet. Have fun.